So hello, welcome to today's lesson. So today we are going to talk about the normal distribution, and our main focus is to be able to solve this question here. So the question says that the height of a group of footballers are modeled by a normal distribution with mean 186 centimeters and standard deviation 4.9 centimeters. The weights of this group of footballers are modeled by a normal distribution with a mean of 80 kilograms and a standard deviation of 6.8 kilograms. So we are supposed to find the following probabilities. So this question is on a normal distribution, and before we can solve that, we have to know one or two things with a normal distribution. So to make the understanding clear, we'll go through the normal distribution, a summary of it, before tackling this question. And so I'm Boydo can read off a dear students of mathematics KNUSD, and please don't forget to like the video and please subscribe to the YouTube channel for more videos as such. Thank you. So let's start. So the normal distribution. So the normal distribution is one of the most widely used probability distributions for modeling random experiments and mostly continuous random variables. So it provides a good model for continuous random variables involving measurements such as the height or weight of person. So you can see the question there. We had height and we had weight. So the normal distribution is better for doing this. Then time, amount of rainfall, growth rate, and many other scientific measurements. So that's the normal distribution for you. So if a random variable x is measured by the normal distribution with mean mu and variance sigma squared, then it is simply denoted by this, as we can see here, and here the x happens to be our random variable, and this means this is the sign here, and this is n for the normal distribution, and it has two parameters, so mu, where the mu stands for the population mean and sigma square stands for the variance. So that's a representation. So now, how do we compute probabilities involving the normal distribution? So we use what we call the z-score. So the z-score is giving us, our z here is giving us s bar minus mu over the standard deviation. So this is the variance, but note that the standard deviation is just equal to the root of the variance. So that means that the standard deviation will be equal to the root of sigma squared, which will give you sigma. That's why you see sigma here. So this x bar stands for the sample mean, the mu stands for the population mean, and our sigma stands for the standard deviation. So this is the formula for computing the z-score. It's a very important formula as far as the normal distribution is discussed. So let's take note of this. So we then read the results from the normal table. This can also be read from the calculator. So mostly we read our results from the standardized normal table, and we can also use the calculator to find our readings, and I'll take you through both of them. Alright. So this is to enable you to know almost everything regarding the normal distribution and prepare you effectively for exams as well. So note this important formula for computing the probability. So when you have phi of minus k, it's just giving us 1 minus the phi of k. So you see here it was minus here, so it can just be 1 minus phi of k, then here it becomes positive, which is the same as 1 minus the probability that z is less than or equal to k. So don't worry, I know as you are going through now, it might look a bit difficult for you, but as we start applying it to solve examples, you realize it is very simple. Okay, so just try your best to follow along and don't be discouraged. It's not difficult at all. So the probability that our z is greater than a certain k is giving us this here, so it's giving us this here, which is also giving us this. Then the probability that our z is less than k is giving us phi of k, and the probability that our z is between a and b is given as the phi of b, that's the b here, minus the phi of a. Alright, so these formulae, they are very important, but as I said, I know stating them here now might not make sense to you, but as we use them to solve examples, you realize it's very simple to comprehend. Okay, right, so let's take examples. So we are just learning how to read a probability using a normal table, because if you can't do that, then you can't solve any question regarding a normal distribution. That's the most important thing we do here. So we are to find the following probabilities using the normal table, and this is the first one, this is the second one, and this is the third one. So remember that we said that when you have probability of z being greater than a certain k, this was giving us 1 minus the phi of our k. I hope you remember something like this. Let me show you up here. So this is what I'm talking about. Probability of z greater than k is giving us 1 minus phi of k, this thing here. So you see, as you are solving questions, those formulae are becoming relevant. So here our key is 2.63, so the probability of z being greater than 2.63, which will equal to 1 minus phi of 2.63, right? So that's what you can find here. And so when we have this, what we do is that we read this here from the standardized normal table, and you can also punch it directly on the calculator, right? So as we proceed, I'll teach you how to do that. So when you read this on a normal table or punch it on the calculator, you get 0.9957, and the final answer gives you 0.0043, right? So right now, let's learn how to read this from the normal table. So phi of 2.63, right? So let me go to my normal table. So this is how the normal table looks like, right? So these are values for when you have negative values, but we are talking about 2.63, so that means our values are positive. So we come to where we have positive values, as you can see here. So here you realize that the value that we are trying to read is 2.63, so we look for 2.6. So you realize this is 2.6. Hope you can see it. Yes, then it is 2.63. So what it means is that the values here is 2.60, this is 2.61, and this is 2.62, this is 2.63. So that means that the value for 2.63 will be found here, matching it to where we had our 2.63. So 2.63, so this is 2.6, this is 0.03, so it is 0.99573. I hope you can see that, 0.99573, and that's definitely what we can see here, 0.99573, but we rounded it over to 4 decimal places. That's why we have this. So that's the solution to the first question. And the second question says that probability that our z is less than or equals to negative 1.95. And remember we said probability of z being less than or equal to k is the same as phi of k. So let me show you. So you realize that it is here. So this formula here. So I hope you're now seeing the importance of what we learned, right? So this is the same as phi of negative 1.95, which is 0.0256. So let's just try to read these two from the table, okay, so that you know how we do that. So we are reading phi of negative 1.95, right? So when you go to our table, so this we have to go to the negative part. So this is our negative 1.9, right? But it is 1.95, so we have to look for where there is 0.05. So you see 0.05 is here, so that's 1, 2, 3, 4, 5, 6. So it can be found here. So we match it to where we can find our 1.9, negative 1.9. So this is our negative 1.9. And remember, we counted 1, 2, 3, 4, 5, 6. So that means it is over here, right? So negative 1.95 is 0.02559. And when you um convert this to four decimal places, you get 0.0260 and 0.0256, sorry. And as you can see here, so that's how we read from the table. I hope it's a bit clear. Then this is also this reading. So this one, remember we said that probability of A being less than or equal to Z, less than or equal to B, is just phi of B minus phi of A. Right, so as you can see here, and when you read this from the table, you get this. So I know you can do that. So please, what you've done very so far is very important, especially reading the probability, because any question involving the normal distribution will tell you to compute the probability. So no matter the formula you know or anything, if you can't compute the probability, that means you can't find the answer to any of the questions involving this normal distribution. I hope you get it. So now, using a calculator to when you have your Casio calculator, how can you use that to compute the phi value? That's the probability that you were computing without using the normal table. So you go to mode on your calculator, then you choose 3, where you can see start there. Then after that, you hit on the AC key on the calculator. Then you press shift. After pressing shift, you press 1, choose 5, where you find something like this Q. Then you choose 1, which has something like this. Then you type in the value for phi. So if let's say it is phi of k, you type k there. It is phi of 2.91. You type 2.91 and press the equal to sign, and you will get your answer. Okay, so that's the procedure. But don't worry, we'll try and get a video to illustrate it whilst we do it on the calculator for you too. Alright, so don't forget to subscribe so that you'll be notified of that video. Alright, so now we are done with all the important things you have to know before we can tackle any question on the normal distribution. So now let's try to tackle our question. So let's go back to our question and read it. So it says the height of a group of footballers are modeled by a normal distribution with mean 186 centimeters and a standard deviation 4.9 centimeters. So let's come back here. So the height, the mean is 186 centimeters and the standard deviation is 4.9 centimeters. Right. So remember that we said that with the normal distribution, it is denoted by something like this. I hope you remember this. We stated it in our earlier discussion. So here, where the mu is our mean, so here our mean is 186, and know that the standard deviation is just the square root of the variance. So the variance is also the squared of the standard deviation, so which will be 4.9 squared, right? So that's it for the height. Then we go to the weight. So with the weight, so the mean is 80 kilograms, the standard deviation is 6.8 kilogram. So when we let the random variable y represent the weight, then that means you're going to have y is whatever we have here, where this is our mu, this is our sigma square, right? So these are just the notations that we need. Then the question says find the probability that a randomly chosen footballer is taller than 185 centimeters. So it's taller than 185 centimeters. So we come here, sorry. So the probability that the footballer will be taller than 185 centimeters will be probability that x is greater than, you see taller means greater than, so greater than the 185 here. Remember we said probability that z is greater than a is the same as 1 minus probability that s or z is less than a. So this is the same as this. And since it is continuous, less than is the same as less than or equal to. Greater than is the same as greater than or equal to. So we have 185 here. And so and this is the same as 1 minus 5 of z. But our z is a z-score. And remember in our earlier discussion, I said it's given by s bar minus mu over the sigma. So in this question, our s bar is 185, as you can see here, and the mu is 186, and the standard deviation is 4.9. So this is from the question, and these two you can see them here. Check them out. So you see here 186 and 4.9. So we will get this, and when we do this computation, we end up with 1 minus 5 of negative 10 over 49, and we read this from the table, right? So we've learned how to read from the table. So when you read this from the table, then you end up with 1 minus 0.4192, which gives you the probability of 0.5808. So I hope you get it. So get the procedure. I know it might be a bit unfamiliar with you, so but as you ponder over it and try to digest it one by one, you will get it. Right then, the next question says the weight being less than 90 centimeters. Right. So remember that we represented the weight by our y. So let the random variable y represent our weight, and this was the mean and the standard deviation for our weights. So that means with that one, our weight being less than 90 centimeters. Oh, how can our weight be less than 90 centimeters? It's 90 kilograms. So our weight being less than 90 kilograms. So let's see the question. So the question, sorry, this is supposed to be kilogram. I think it is from the source of the question. You know, weight is measured in kilograms. So let's come back to our question. So weight being less than 90 kilograms means that we have y being less than 90. Remember we said that probability of z being less than k is the same as phi of k. It is the same as phi of what? Z. But z is s bar minus mu over sigma. And remember that our s bar from the question here is 90. Then this is from the information given to us. So for the weight, the mean weight was 80, and this was the standard deviation. So when you do this computation, you get 100 over 68. And when you read this to 100 over 68, you convert it to the nearest decimal. When you read it from the table, or if you use the calculator approach, which is very simple in exam, that's what you have to use because very, very simple. You get 0.9293, and you are done with the second question. So let's go to the third question, the final one. So it says, assuming that these footballers' height and weight are independent. I hope you remember what independent events are in your probability and statistics course, right? So we said two events are independent when, so let's come to mutually exclusive first. You see when they are mutually exclusive, then it means that probability of A intersection B is equal to 0. But when they are independent, probability of A intersection B is equal to probability of A times probability of B. So here they are independent, so that means this holds. So we should find the probability that a randomly chosen footballer is taller than 188 centimeters and weighs more than 97 kilograms, right? So let's come to the solution. So it's the probability of a footballer being taller than 188 centimeters and who weighs more than, so the probability of a footballer who weighs more than 97 kilograms. So remember that in probability and statistics, probability, when you say end, the n stands for the multiplication. When you say or, the or stands for addition. So this is just be the probability of s being greater than 188 times the probability of y being greater than 97. And this here is the same as this. I hope you know why. from the rules, right? This is the same as this too. I hope you know why. From the rules, right? Because the rules say that probability of z greater than a is the same as 1 minus probability of z being less than or equal to a, which is same as 1 minus phi of a. So that's what you can also see here, and you can also see here. So when you put in, and this is the formula, when you put in the values, you get this, you get that. So try to analyze it. So this is from the question, this was the information we're given, this was from the question, this was the information we're given. So when you do this computation, you end up with this here, you do this, you end up with this here, and when you read this from your table or compute on the calculator, you get this. For this two, you get this. And the next thing for you to do is just to do your arithmetic computation. So after doing everything, you get your ability to be 2.1179 times 10 raised to the power negative 3, which is 0.00211179, which in round to 4 decimal places gives you this, right? So that's the solution to our question. So if you didn't really understand things, don't worry. You can take your time and go through the video bit by bit. The understanding will come, and also you can ask any question you have at the comment section, and we'll be glad to answer you.